It's an interesting illustration. As we were just talking about heat going into the ground and danger to permafrost. It's funny, if you sort of invert the concern, backing up one step, ground source heat pumps are a very, very common technology in the lower 48 states and many other places around the world. They're typically used for as much as cooling, if not more cooling, as they are heating. Most designs can be just reversed simply to do that. Here, we use it 100% for heating. I don't think we can even have it set up for cooling. And the concern was, well, if you're robbing all that heat from the ground and there's permafrost at some depth underneath you, aren't you just going to bring the permafrost all the way up to the surface if you're just taking heat from the ground? We're just about to enter year 2 or winter 2 and using a ground source heat pump, and it performed really, really well the first winter. Not only did it perform well, but as the fluid circulates, it's a methanol water solution, as the fluid circulates in the ground, it comes back to the heat pump to use. Average temperatures last year were just around freezing. So they weren't super cold like you'd expect. It wasn't, say, 25 or 20 degrees or something like that. There's an enormous amount of energy that's available. You wouldn't think it would be, but there's an amazing amount of energy available in the ground right around the freezing point, because as you remember from, if you ever did these experiments in high school or college chemistry or physics, thinking about the latent heat available as you change phase from, in this case, from liquid to a solid. Freezing that ice cube takes a lot of energy. And you don't change temperature until you stay right at 32 degrees as you're changing water from liquid to ice. So a similar thing happens in the ground, even though it's not a giant ice cube, it's soil with water and air. There's a lot of energy that's available in that soil moisture as we freeze it, as we extract heat right from the ground. That's called the latent heat. And that actually is a huge buffer and part of the reason, just part of the reason why this doesn't become a giant block of permafrost. Because we've done a lot of other heat pump research, we're pretty confident that this is going to work. But part of this project is, as the title says, is to demonstrate the technology to people, that it is an option in the interior Alaska and other parts of the state. And also answer some unknown research questions about exactly how efficient is this heat pump over multiple years. Existing projects that we're aware of have only monitored heat pump performance for a year or two. But if there is this thermal degradation over the course of time, we want to be able to speak more specifically about what its performance is in the long term. Because obviously if you're thinking about one for your house, you'd want to know, how's this perform over time? Very, very different system than the one that's right behind us here. That's a high efficiency oil-fired boiler. You feed it oil, you keep the oil clean, you give it enough combustion air, you tune it every year, it's going to perform great. You don't have to worry about, your ground and whether there's permafrost. Of course, you're using oil. And so, it's a very, very different heating appliance because you have to start considering the ground as the majority of your energy reservoir. So it's a very different shift than what most of us are used to in using oil or natural gas or propane as for our heating.
How does your square footage as such compare to the living space of the building that you're heating?
Oh, that's an interesting question. I don't remember off the top of my head.
I'm thinking in terms of like lot size. If
Yeah.
You've got that, and then you've got your overflow from your septic as such. How big a lot would you have to have to accommodate all of that and your cabin?
Right. So these ground loops is configured here, we call them the slinky loops. They do take up a bit of real estate. If you live in the hills and you have a few acres, it's not going to be necessarily an issue. But what a lot of people do to get around that real estate issue is they have what are called vertical well systems. So very similar to a water well, where you just drill down a few hundred feet. You wouldn't need just one, you would need several.
But just do it vertically instead.
Yeah, you make up that distance vertically. And the advantage of that, one of the advantages of that, even though drilling is expensive, is that you don't need such a large area, you don't have to clear it if you want to keep it forested or vegetated. Is that What's that?
You can put it under your foundation within the footprint of the building.
Well, it's an interesting idea, and it's one we've had as well. Some people have investigated that in what we call mixed climates. They have heating and cooling, and it can work. They literally wrapped the foundation sidewalls with the heat exchangers, but it's been an idea we wanted to pursue in terms of very much on top of permafrost. Can you use that as a way for helping to maintain permafrost as well?
That was
as
my
minimizing.
original thought, is that you have this building sitting on permafrost. Is that part of the refrigeration that's helping mitigate the sinking of the building? Is that that wasn't the intent?
Not in this case. We actually, and we can show you the ground loop when if we go up on the roof and look outside, but the main research questions we had were long-term efficiency. We have a couple different ground covers on top of this, and we're looking at how effectively, say, gravel versus vegetation recover solar input and affect the efficiency of the heat pump.
What depth is your loops? Are your loops?
They're around 10 feet underground. But yeah, no, you have to be careful about putting it under your foundation, because that's been one technique used to repair a house. They installed ground loops underneath it, and they weren't using it to heat the building as the design. They're more or less using it just to stabilize the permafrost. If you freeze it too much, especially in moist soils that are silt like this, you can actually start jacking the house up. And so they had that problem of, oh no, the house is sinking, turn up the heat pump, oh, we're moving the house up, and they had to fine tune it. So it gets to be pretty tricky. But that's definitely a good idea, and I think it's something we'd like to do in the future. So now that we've talked about it, the heat pump is that gray box called GeoSource right behind you. It's rather, it's pretty incredible in what it does, but the actual packaging is not that dramatic. Its function, even though it's very different in the specifics, it's much like your refrigerator at home working in reverse. Uses a bit of electricity, and it uses heat from the ground just moves heat from the ground and steps it up in temperature to heat the building. Here is a wood pellet boiler that we use to heat the building addition, which is everything on this side over here. And it's been something that in the interior has been pretty popular lately. Notice the theme here is we're really looking at alternatives to oil. As we all know, oil is very expensive, and people are interested in options. What else is out there besides oil? And before we get something like natural gas, and we won't take any bets about if and when that happens, there's options like the ground source heat pump and biomass in the form of wood pellets. So in this case, we have on the little lean-to structure next to us, we have a storage hopper of sorts that feeds this. It's not connected right now, but it would come through the wall and feed into this into the storage bin, or an automatic feed to this pellet boiler. So it's as close as you're going to get to the relatively low maintenance, or you don't have to stoke this like a wood stove. It's kind of like the heat pump or the oil-fired boiler. As long as you keep the fuel supply stocked, it's going to feed itself. So we used this last year as its first year for heating the building addition. And the pellets we use, interestingly, come from a local supply, Superior Pellets. They use local interior wood sources to make wood pellets, and that's what we burn here.